Well, g'day, Max there again. Welcome back to the shop. So in this video, we've got some long shafting to play with and some splines to cut on either end of it. So in a nutshell, we've got a 3 metre long shaft with a splined end on either end. So we are going to be using a fair amount of our shop-made tooling. So we'll be using our tailstock chuck, our lathe spider that we made for this machine, and the angle plates and extension plates that we made over the last couple of weeks, and that will all help us get this job through. So I have a dummy shaft in the lathe here, which I'm going to run through the milling machine. It's just for confirmation that all our setups are correct, as I don't want to start chopping into the new piece of shafting on a completely unknown setup. So let's bring you down and explain, we'll walk you through where we're at. So the piece of shafting we'll be chucking up is 1.5 inch diameter by 4 meters long. So it will require the use of our lathe spider, as we'll have a fair bit hanging out. Off camera, I haven't finished it yet, but it's finished up enough to use. I made this steady rest riser. So this is the steady rest off the JFMT lathe. And we just made an adapter to fit our Heron lathe. We'll be using our homemade tailstock chuck. And in the red protective cardboard is that's the new piece of shafting. So I've got a shorter piece in the lathe at the moment, and we've just turned down to the OD of the spline we have to cut, which is 1 3/8 inch by 21 teeth. Now that step I've turned down is the minor diameter of the splines as per calculation. So we'll see if that all rings true when we go to do a test fit. So I have a spline coupling here, and that's what we have to make our shaft to suit. So I'm at the stage now where we need to get our cutter, which is this one here, 1 3/8 inch by 21 spline, 30-degree pressure angle. These aren't cheap either. Yeah, that is not a cheap cutter, but it is the correct cutter for the job. So yeah, well, in a nutshell, I'll show you a different way, an alternate way or another way to get our cutter centered. I did have to make off camera a couple of risers for the tailstock, and I made up also off camera a backing plate for the small 6-jaw chuck. This backing plate will end up being the one for our smaller rotary table. I would like to get probably at least a 10 or 12 inch chuck on this rotary table on a backing plate, but that still has to happen. Also off camera, I had to machine this adapter because this rotary table was missing all of the cranking gear. So I just purchased a small, comes as a kit, handle index plates, and cheap and cheerful. And as soon as I've done this job, it's probably going to go in the bin where it belongs. And I'll get a 6 inch, at least a 6 inch diameter set of plates, because these are way too small. But at the time I thought, oh, it'll do what we need, but yeah, hindsight, no. But it should get this job done. What the problem is, your cranking center, well, from your crank to the center, because we're working on this inner ring of holes, it's just too close together, it's too small. So yeah, so you can see our backing plate that we made the other week in the other video, the angle plates, which we still have to machine the rear of, and the hole. The rotary table has a 65mm bore, Now, due to the length of the shafting and due to we're only gripping on such a small length of it with the small 6-jaw chuck, we will be running an outboard support with a steady rest, and then further yonder we'll hang the shaft off the block and tackle. So let's get our cutter mounted up and centered, and then we can get that piece of shafting and out of the lathe. And what I want to do next is see how we're going for clearance between the cutter and the tailstock here. That will determine how we machine the end of the shaft, whether we have to machine a false extension and then cut to length after the splines have been cut is our worst case scenario. But let's get our cutter mounted up. Okay, in an earlier gear cutting video, I did sort of briefly go through to check the cutter to make sure the actual profile on the cutter was ground central to the thickness of the cutter, because that will determine how you set the height of the cutter. It's more important that the tooth profile is on center rather than just going straight for the width of the cutter. Now this cutter, that was pretty difficult to do, but I'll show you. All I did was, sorry for the shaky handheld, but it's just the way it is this morning. I just put the cutter up against this piece of aluminium, scribed a very light line across, turn the cutter over, same, and just see if our scribe lines or the impression left by the end of the cutter matched, and they do. And our tooth profile does appear to be on center as expected, because yeah, it's not a $2 cutter. And this is a folder that I've started to keep for new steel, so I know exactly what the steel is, where it's been used, and put job number, and the test certificate for the steel. So most steel comes, there is test certificates available. So depending on who, where, what the job is for, some people will ask for it, some don't. But it is important information to have, especially like like this one here. This is for pre-hard 4140. It's got all the heat treat information on it and where it's made and all of that sort of malarkey. It's just a background record, which is important information to keep. So to get our cutter on center, this smaller diameter I've machined here is the same width of the cutter. So we just need to bring the knee up until it contacts the underside of these bushes, till there's no more play left in there. So when you do set your height, you've got to balance your height lift with your knee lock, because when you lock the knee, it's going to change what you're ending up with here. So my knee's locked now. I've got ever so slight play there. So if I unlock the knee, we'll just come up a fraction more. .1 of a millimetre. I can feel I've got pressure on that now, but I can still wiggle it, so. Yeah, if you set your height here before you lock the knee, this will change. So, right. Okay, that's our cutter locked on. So we're just checking our cutter here and we're running half a thou run out. It's got one spot in the cutter, it's got like a half thou high spot. That's fine. Okay, we're just going to take a little cut on the end of this part, then we'll rotate it 180 degrees and just verify our centre height. Okay, that's half a turn. We're just going with the Sharpie. And just visually looking, that looks pretty good. Right, we can get this little piece of material out and get our shafting in. So we got our steady rest in location. I did change these blocks underneath it as we're just a bit off with height. So our bar's sitting nice and level, as with the level of the machine. So what we've done now, just indicated in the tailstock. Now this is a fully adjustable tailstock in height and everything. So we're looking that we are about the right height. So what I need to do now is set the indicator up in two planes, a vertical and a horizontal planes. So when we engage the point of the tailstock, we're not influencing our bar stock. So we've got a close enough reading on our indicator for lengthways. So yeah, we'll set the indicator up on our part now. Okay, so we've indicated in our part, so when our center is engaged, we get minimum deviation of the part in the vertical plane and the horizontal plane. So I've also added a couple of hard stops because we will have to remove the tailstock out the way at some stage for a test fit. So these hard stops will ensure the tailstock comes back into a quick alignment and we're not mucking around indicating it back in every time. So we're blued up there, so we'll come in till the cutter touches and then we'll take a cut. Right, let's make a start. I'm running our cutter on 100 RPM and our feed rate will be 40 millimeters a minute. It's very hard to get into this machine to see. Okay, I think we've got a good touch-off point there. So we'll just set our knee dial on a whole number. I will be relying on the indicator for our travel, 100%, as the knee dials will get you close, but this is a very big machine, so there's a lot to take up. A lot of things have to load up and start before things start moving, and that's where you get a little bit of variation on your dial down there. And we've also plugged in the old microwave oven, so we'll make sure all of this is all zeroed off. I was actually looking for the door on this thing where my pie and sausage roll go to get warmed up, because it looks more like a bloody microwave oven. It's about the size of one. So this will get replaced later on with a more modern version, as it's got some issues. Alright, let's get you set back up. I have an oil bottle set up so we can drip feed cutting oil onto the cutter and we'll get a cut happening. I do not have good lighting on this side of the machine, so I might see if I can set you up in a better spot. What I do want to check is our indexing, so let me check that. I want to verify all that first. So we're just verifying our indexing now, and the next index around should bring us back to our starting tooth. We're looking pretty good. Yeah, we're there. Camera angle back then made it look like we're off a touch, but yeah, depends on your camera angle, but we are right on it. So we're good to go. Well, you get the idea. It's going to be a long, slow process, so I'll bring this back when we're coming around a bit further. Well, I'll progress with this off camera till we come all the way around to our starting position so we can get a measurement. A little drip feeder bottle I stole off our rotor broach drill, slowly dripping a metered amount of cutting oil onto the cutter, working very well. I'll show you a trick for the uninitiated with regards to indexing. Because this is so small and I've never indexed off this rotary table before, and it's very easy to make a mistake on this small plate. I've just drawn a mark across it, so every index, when I go to move the sector plate, if they don't line up with the previous white mark, I know I've made a mistake in that index, so I can correct it before we take another cut. If you do it for every indexing, you'll find you'll get a series of marks around the plate and they will always line up. So if you go to index and it don't line up before you take your cut, you know you've made a mistake. So yeah, I'll carry on. Okay, we're just coming up to our last cut. Right, we've got our trial piece out of the machine, and as far as our setup was concerned, it all worked out well. What I did find was this 21 tooth spline isn't quite the standard spline that it looks like. The one that we've just cut should be a fraction deeper than what it is, going by calculations. Like, it's a good fit and there's hardly any play, very minimal. Like, that's quite a standard spline fit. This one here, it's more of an interference fit. So what we're going to do, measurements across wires as they are. This one's 0.1 of a millimetre bigger when measured across the wires compared to this one. So we'll get our proper piece machined up now, we'll put it in and we'll pull up 0.1 shy of where we were with this one, and it'll put us right on where we need to be in relation to this one. But yeah, it's a bit, that end's really tight. Like, you'd have to flog that on with a hammer. That end's even tighter. So might just be a tolerance variation. So anyway, we know where we're heading and we know our setup's going to work. So we'll get our proper piece chucked up in the lathe and we'll get the first end done on it. So at first thought, I thought it might have been maybe the angle of the spline slightly different, as there's quite a few variations, but bluing this one up, not to be. So we are we do appear to have the right cutter. So we'll move on. So this is the shaft we're going to be making our new part out of. It's 4 metres long, our part's 3 metres. I don't really want to cut it, so we'll see if we can't get the whole length accommodated in the lathe. So we will be using our lathe spider with this one, as we will have a fair bit hanging out the back. Still, that's why we made the spider. At least my arms are a bit better this video. Must look like a crackhead in the last one. It all burns up my arms from hot chips off the Bridgeport, and didn't actually realise how bad they were. They'll get you. Okay. That's close enough. Well, this is as close as we're going to get with this indicator. It's just too jumpy. It just reads all over the shop, this one. Always has done since new. I slide the steady rest down a bit. We have to get a centre in the part. This will be the last cut. Spot on, 1 3/8. So 6 inches back from the shoulder, we're just got to do a little step, and this step we'll turn it down to the idea of the spline, and after we've cut the splines it will get chopped off. It'll be a sacrificial piece to allow clearance between the cutter and the tailstock in the milling machine. 14th hour to go. That's okay. I left that 1/3 hour above finished size for the root of the tooth, so that gives us that little bit of leeway if our cutter touches, once we see our cutter touching that in the milling machine, we know we're on size. So yeah, I'll get a radius tool set up, so I just want to put a radius in this corner. As I mentioned, this is 4140 pre-hard. Should be alright. I'll give it a polish up. Right, so that's this end done, so we'll get it set up in the milling machine and we'll do our splines. Might have to open the roller door, I think, to get it in the machine. She's just that tad too long.